Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about the classification scheme for various types of ferrous alloys. So before going to the classifications of these alloys, first of all we have to know what is the difference between the ferrous and non-ferrous materials. Okay, so metals alloys by virtue of composition are often grouped into two classes. So what are the metal alloys are there? These have been classified into two classes. So that is the ferrous and the non-ferrous. So ferrous alloys are nothing but in which the iron is the principal constituent. So what are the ferrous alloys are there? In this ferrous alloys we have mostly the principal constituent as iron. That includes the steel and the cast iron, and the non-ferrous alloys in which there is a not iron based. So that is the main difference between the ferrous and non-ferrous alloys. So generally the metal alloys have been classified into two classes. So what are the two classes here? You have the ferrous and the non-ferrous materials. And the ferrous materials in which you have the major constituent as iron, that is the steel as well as the cast iron. And coming to the non-ferrous alloys, and these are not iron based. So that is the main difference between the ferrous and non-ferrous materials. So what are the ferrous alloys here? Those of which the iron is the prime constituent. So the major constituent in this ferrous alloys is the iron, which are produced in large quantities than any other type of metal here. Why? Because you have a large number of applications. When you see the daily usage, we have the most ferrous alloys we are using when compared to the non-ferrous alloys. So they are produced very large scale, and they are especially important as engineering construction material. So that's why these are very important construction applications. So that's why there is a large amount of production in this area. So their widespread use is accounted by three factors. So what are the three major factors in these ferrous alloys? Means iron containing compound exists in abundant quantities with earth crust. So why we are developing or why we are producing large scale or large amount of these ferrous alloys means the first one is what? The existence is very high when you compare with any type of metal alloys. Why? Because in the earth crust you have a lot of iron which exists in the earth crust. That's why the production rate is very high. And the second one is metallic iron and steel alloys may be produced using relatively economical extraction, refining, alloying and fabrication techniques. So why we are going with these ferrous means the refining of the material or the manufacturing of the material or the fabrication of the material, alloying of the material, and also the extraction is very economy when you compare with any type of alloys. So that's why this is the second thing why we are going with these types of ferrous materials. The third one is ferrous alloys are extremely versatile in that they may be tailored to have a wide range of mechanical and physical properties. So not only the availability is very good, and also the flexibility of manufacturing. Apart from this, we have the other things is it is very versatile use, extremely very versatile, and this can be tailored or manufactured in any forms of things, and you can enhance the properties of like mechanical as well as the physical properties. So if we see the classification of these ferrous alloys, so these metal alloys have been classified into two categories, that is the ferrous and non-ferrous. So ferrous is nothing but the pure iron based, and non-ferrous means not iron based. So the alloys which are of iron based are called the ferrous, and the alloys which are not of iron based are called non-ferrous materials. And these ferrous again are classified into steels and cast irons. So in the earlier session we have discussed about the classifications of steels as well as the cast irons. So how we are classifying? With the help of the phase diagram we are trying to classify whether it is a hypoelectric or hypoelectroid steel. At the same time, hypoelected cast iron or hypoelected cast iron. So how we are getting all this information? With the help of the phase diagram. Okay. Now these classifications of the ferrous also we can classify into the steels as well as the cast iron based upon the composition of the carbon content present, and this information we are getting from the phase diagram. So how we are classifying all these categories means with the help of the phase diagram only we are trying to classify all these classifications, that you have to remember very carefully. And these steels again classified into low alloy and high alloy, and the cast iron are again classified into gray iron, ductile iron, white iron, malleable and compacted graphite iron. So all these classifications again we are getting all these classifications with the help of the phase diagram only. Just we are not writing all these things, we are observing the microstructure, how it is being there, as well as what is the composition at each phases we are seeing, and that depending upon the phase diagram only we are trying to classify all these classifications of the ferrous as well as the non-ferrous materials. Now these steels again into low and high, and again in the low alloy we have low carbon steel, high carbon steel and medium carbon steel. And this low carbon again plain, high strength, medium carbon is also plain heat treatable, and high carbon is also plain and tool. The high alloy is also at tool and stainless steel. So all these classifications, all these categorizations, all these characterizations, we are getting the information completely from the help of the phase diagram. That's why the iron carbon phase diagram is very important in classifying all these classifications of different types of cast irons or different types of steels, and also to differentiate between the ferrous and non-ferrous materials. Also the iron carbon phase diagram is very important. Now coming to the steels, steels are iron carbon alloys, of course, that may contain appreciable concentration of other alloying elements. There are thousands of alloys have different compositions when heat treatment process. So while doing the heat treatment process, we can add some of the steels to the different alloying elements and to enhance the mechanical as well as the physical properties at each stage. The mechanical properties are very sensitive to the content of carbon, which is normally less than 1 weight percentage of carbon. So generally if you see the steels and iron, it is having a less carbon content of at least 1 percentage of the carbon content. Some are more common steels are classified again to low, medium and high carbon steel. So how we are classifying all this carbon, whether it is a low carbon or high carbon or medium carbon, is based upon the percentage of carbon content, weight percentage of carbon content. From 0.02 it will reach us to 1 percentage of carbon. So during these changes of the percentage of the carbon content, we are differentiating whether it is a low carbon steel or medium or high carbon steel. So what is low carbon steel means? So what are the carbon content is there? So depending upon the weight percentage is, so generally which is less than 0.2 weight percentage of carbon content is present, then that type of category is called a low carbon steel. So low carbon steel which has 0.2 weight percentage of carbon content, then that type of steel is called as a low carbon steel. So all these classifications we are getting depending upon the weight percentage, composition weight percentage of carbon content. And in the sequence, these alloys are relatively very soft. If you see the physical properties of these low carbon steels, with very soft and weak but have high ductile nature and toughness, and these are very easy for machinable, weldable, and all steels are at least expensive to produce. So if you see the mechanical properties are very soft and weak but has a good ductile nature, good ductility. Also the toughness is also very high, and because of this ductile nature it is very easy for machinable. And typical applications of these low carbon steels which are included in the automobile body components like structures, shapes of iron, I-beam channels, angle iron, during the construction of the bridges, all these things can be used with the help of the low carbon steels. And the pipelines, building bridges, okay, tins, water can tins, the aluminum tins what we are using, all these things comes under the low carbon steels. Coming to the high strength low alloy, again you have between the medium and low, you have the high strength. So in this category we have the properties are high strength low alloy HSLA steels. So these contain the other alloying elements such as copper, vanadium, nickel and molybdenum, so which has a high concentrations, about 10 weight percentage. Because of addition of these other alloying, what is happening, the strengths are increased. So we can increase the properties by adding some alloying elements during the heat treatment process. That's why if you know initially what type of properties does this material will have, if I want to increase the property of that material, I can do the heat treatment process to that. I can add some other elements or like alloying other elements into that, and I can improve the properties of the material. So if you see the mechanical properties of these high strength low alloy, it is very ductile, formable and machinable. So these three are the mechanical properties. And if you see the applications where you can use these, like bridges, towers, support column, high-rise buildings and pressure vessels. So these are some of the examples where you can use these things. So if you see the individual composition of these low carbon steels, so these are the plain low carbon steels. So depending upon the carbon content percentage, so you are classifying different types of materials. So based upon the grade, we are classifying the weight percentage of carbon content, and depending upon these, we will have the different mechanical properties. Based upon the properties, we can use them to the required application. So whenever you are selecting any material, first you have to know what is the composition. After knowing the composition only, what are the properties, mechanical or physical or chemical properties can be identified. Once you know the properties, then only it is applied to the required applications. You have n number of applications. So how to select those? For those applications, the exact material means if you know the exact composition, so once if you know the exact compositions, then it is very easy for us to apply to that material. Similarly, high strength low alloys, so there is a difference, or there is some increase in the carbon content. So 0.28, 0.22, 1.8. So these are some of the grades what we can see here, and depending upon this, again also we can alter the application. So that is about the composition weight percentage. Now as I told, so depending upon those compositions, we are classifying this, and based upon these classifications we have the typical applications. Why? Because these are some of the mechanical properties what we have. Based upon the mechanical properties, now suppose if I see this 1010 type of steel, it can be used in automobiles, panels, nails and wires. So if I want any other structural building applications, then I have to go with this A36 type of steel. Suppose if I want for truck frames of railway cars, then I have to go with this type of grade of steel. So all these classifications are based upon the composition weight percentage of carbon. Based upon the composition weight percentage of carbon, we are getting some properties of mechanical and chemical, physical. Based upon those properties, we are justifying our application. So depending upon this application, we are selecting that material. So this is how the procedure you have to follow while selection of any type of material for this application. In coming to the next stage, you have the medium carbon steel. So medium carbon steel ranges in between 0.25 to 6.6 percentage of carbon, and these can be heat treated by austenizing, quenching and then tempering to improve the mechanical properties. And also most of the these medium carbon steels can be utilized in the temper conditions. And you have the addition of the chromium. If you add some of the alloying like chromium, nickel, molybdenum, it improves the capacity of the alloys to give rise the structural ductility combination. So if you want to increase the mechanical property like the strength and ductility, we can add some of the alloying element like chromium, nickel and molybdenum to this medium carbon steel. So like that, if you want to improve the mechanical properties, you can add the chromium, nickel and molybdenum to improve the mechanical properties for the medium carbon steel. Now, if you see the mechanical properties individually, so what are the mechanical properties means? It has the good ductile and toughness nature. So because of these ductility and as well as toughness in nature, You can use these medium carbon steels in the tracks of wheels, gears, crankshafts, and other applications of the mechanical parts. And also, by adding the combination of different types of alloying elements, you can increase the strength, wear resistance, as well as the toughness of the material. Now, the other category is the high carbon steel. So, in this high carbon steel, what is the composition rate means? From 0.6 to 1.8% of carbon. So, what are the elements or what are the alloys which are in between these 0.6 to 1.48% of carbon? You can have the high carbon steel, which is having the hardest, strongest, and ductile nature. They are almost used in hardened to temper conditions, where you can add these type of materials for holding and a sharp cutting edges. So these are some of the applications of the high carbon steel. If you see the mechanical properties of these high carbon steels, which is having a good toughness. Now, by adding the chromium, vanadium, tungsten, and molybdenum, so other alloys, if you add, you can more increase the alloying element by adding these things, and you can enhance the mechanical properties. So that's why it is utilized as a cutting tool. So cutting tool are used in case of high carbon steels, and also die forming, shaping of materials, knife, razor, hacksaw, all these things are used or applied with the help of the high carbon steel. So based upon the composition of the carbon content, so we are using these things of applications where you can use in razors or knives or everything. So coming to the stainless steel is a high resistance corrosion. Any material which is exposing to the different climatic conditions, it will directly go to the rust formation. So in order to control this resist from the corrosion, we are using these stainless steels, and the predominant alloying element in this stainless steel is chromium. A concentration of 11 weight percentage of chromium is required in order to control that corrosion resistance to the material. And also you can enhance the corrosion resistance also by adding the nickel and molybdenum additions also, but the major constituent in this stainless steel is the chromium. So as we discussed in the previous session, the cast irons are classified. Steels are also classified based upon the iron carbon phase diagram. So based upon this iron carbon phase diagram, we are classifying the cast iron as well as the steels based upon the composition weight percentage of carbon. So based upon the composition weight percentage of carbon, these have been classified. So again, we are getting the cast iron by decomposition of iron carbide into the ferrite and graphite. So this also we have seen in the previous sessions how it is being forming the graphite. So how we are getting the graphite? So after crossing that 6.7 weight percentage of carbon content, so we are getting this cementite, that is the graphite. So this is the decomposition of the iron carbide to form the alpha as well as the gamma ferrite. Now equilibrium diagrams we are seen. So what is the equilibrium diagram? It will show the equilibrium phases which are existing in the phase diagram. So what are the equilibrium phase diagrams here? The cast iron below figure extends the 100 weight percentage. So see, you can see here in generally we are taking up to this percentage only, 6.7% only. If you cross the 6.770, we are getting into graphite nature. So this is the second part, another part of the iron carbon phase diagram. Now the classifications of cast irons. In this cast iron you have grey cast iron. So these grey cast iron vary between 2.5 to 4.8% of the carbon and 1 to 3% of the carbon content which is existing in the system. So what are the black things you are seeing? The graphite flakes. So all these are the graphite flakes. Because these are arranged in the form of a flake system, that's why it is called as a grey cast iron. So mechanically grey iron is comparatively weak and brittle in nature. In tensile force, when you apply any tensile force, these grey cast iron will appear to be very weak and brittle in nature, and the tips of the graphite flakes and the sharp pointed may serve as a point stress concentrations. That's why these are very brittle in nature. And these grey cast irons have been used in desirable characteristics, very extensively used in damping, vibration controlling. So in order to control the vibrations, okay, when you are machining any with high amount of pressure, if you want to decrease the amount of vibrations, then you have to go with the help of the gray iron. So if you are normally you are using, so these are the vibrations you can observe. But once if you use the gray cast iron, the vibrations can be reduced. So that is the good application of the cast iron. Then coming to the white cast iron, again if you observe the white patches, so depending upon the formation of the graphical representation or the microstructure view, we can tell what type of a cast iron it is. Now in this contain less than 1% of silica, then that type of thing is called as a white cast iron. And fracture surface which is having a white appearance, so in this case you can see wherever you see the white appearance in there, then that type of system is called as a white cast iron. And these white cast iron has a very limited applications, because very hard and wear resistance without high degree of ductility, and these can be used in the rollers in the rolling applications. Then coming to the other type of thing is the malleable cast iron. So this is the intermediate to the white cast iron and the grey cast iron. In between the white and grey cast iron, you can observe the malleable cast iron. So this is how the microstructure of the malleable cast iron can be observed to the microscopes. And again, as we discussed in the previous sessions, so depending upon the type of grade, depending upon the composition weight percentage of the carbon, we have the different types of mechanical properties. Based upon the mechanical properties, you have a number of applications. So if you know the application, then you can select the type of material with respect to the mechanical properties. Suppose if I want to make any gear rollers, which type of metal I have to go? I have to go with the 120-90-02. Again, if you want to go with the diesel engine casting liner cylinders, then I have to go with the SAE G4F12. So like this, the selection of material is very important based upon the carbon content percentage, and all this information we are getting from the phase diagram. That's why the phase diagrams are very important in describing any type of things, in selection of materials, in selection of any type of materials, or classifications of different types of steels or different types of cast irons. Everything can be inferred from the help of the phase diagram. So these are some of the references where you can get the information about these materials, difference of the different types of materials, where the steels or the cast irons, or different types of ferrous and non-ferrous elements. First one is the Introduction to Physical Metallurgy by Sidney Heverer. The second one is Essential of Material Science Engineering by Donald. Third one is Material Science Engineering by Kodigiri, and the fourth one is Material Science Engineering by William Castler. So these are the references book where you can get the information of all these different types of steels as well as the cast iron. Thank you for the session.
Like, share and subscribe. Hit the bell icon for more updates.